we get into today's lesson, which is on the coordinate plane, I wanted to mention to you about this man by the name of Rene Descartes. When I look at this picture, he reminds me of a cross between Sean Connery and the Guy Fawkes mask from V for Vendetta. Whether you remember that, I don't know, but that's what he reminds me of. Anyway, Rene Descartes was basically this brilliant man who lived over 400 some years ago. And he's known for three main things. Well, at least to me, he's known for a lot of things, but there was one thing that he wrote called The Meditations of First Philosophy. That's a pretty big book. I think he wrote it in the 1600s, 400 years ago, and that book, even today, is still being held as the standard for modern philosophy in college. And then he's also known as this great master mathematician. Case in point, what we're getting ready to talk about now, the coordinate plane, was once called the Cartesian plane. It still is. It's named for him because he designed it. Now, over the years, people have tweaked it and made it a little bit better, so we've called it the coordinate plane now, but it's still, he was the father of the coordinate plane. And then there was this last thing that I always remembered probably from a long time ago. It was just a quote that I always thought was interesting. I think, therefore I am. I always thought that was a really good quote because it's got some truth to it. If you think you are something, then eventually you will become it. Not extreme cases, but let's say if you think that you will succeed at something, and you can do that as long as you're trying hard to do so. Doesn't mean that you're going to, I think I'm going to win this basketball game and I'm going to, no, that's not what we're talking about. What we're talking about is I think I'm going to succeed in life. I think I'm going to do these things. And if you believe it enough and you work hard enough, you do become it. The best example I could give this is probably what a lot of you as my students already are saying right now. I heard it from day one. I'm not good at math. Well, you're thinking that. I think, therefore I am. I think I'm not good at math, therefore I am not good at math. So if you can get that in your mind and start saying, I think I can try and be better at math. I think I can do better at math. Not, I think I'm going to get an A. Don't do that because that's an expectation that's not realistic. But if you can say, I think and I believe I can do better as long as I work for it, then you are. I am. I think I can do better. Therefore, I am doing better. I am applying for myself. But anyway, I just wanted to share that particular quote with you today because I just about Cartesian plane before we begin because it always meant something for me. I think, therefore I am. So enough of me doing my little rant here. Let's go ahead and get into the video and talk about the Cartesian plane, aka the coordinate plane. So before we actually start working on the coordinate plane itself, let's just go through some definitions. First off, there's what we call the y-axis. It is the vertical number line. The x-axis, which is the horizontal number line. Quadrants, 4 regions of the coordinate plane. Ordered pair is a pair of numbers that represent a point on the coordinate plane, and they're always written in parentheses and written as x, y. X meaning the x coordinate and y meaning the y coordinate. And lastly, origin is the point at 0, 0 where the x and y axis cross. So pause the video if you need to and write these definitions down, and let's talk about what each thing really means. All right, so hopefully you have written all your definitions down. We're going to go through them. So let's talk about the y-axis. It says that it's the vertical number line. We'll recall the word vertical. Vertical always means up and down. So this right here is my vertical number line. How do I know? Well, 1 is usually in the middle of your graph. Not always, but usually. And it's also labeled. Notice how it's labeled. 1, 2, 3, 4, 5. And then we have nothing here, but then it goes -1, -2, all the way down to -5. So this is my y-axis. So we can actually label that. And we can say y-axis. All right. Well, the x-axis definition. Well, the x-axis definition says horizontal number line. So here's my horizontal number line. You can see it. It's the main one. It's located generally in the middle of the graph, even though not always, but most of the time. And it's usually written kind of dark, and notice that it's labeled. So this would be my x-axis. Okay? Now we have quadrants. So if we look at it, we have a quadrant here because these two lines split this entire thing into 4 major things. And we label it quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Uh-oh, what just happened? Think back. You may not know this, but this is what we call Roman numerals, just in case you haven't heard this before. This symbol right here represents the number 1. This represents 2. This represents 3. And this represents 4. It's very rare that we use Roman numerals anymore, but when it comes to the coordinate plane, this is about the one thing I ever see Roman numerals used regularly, is identifying the quadrant. So quadrant 1, quadrant 2, quadrant 3, quadrant 4. And notice that it doesn't go clockwise, it goes counterclockwise, all right? Then we have an ordered pair. This one's a little bit difficult to understand at first, but let's start with the origin, okay? So the origin stated that the point is at 0, 0. Well, that's right here, okay? Right here, right at that point, okay? Why is this 0, 0? Well, if you look at it, the x value right now is 0 because look, there's -1, this would be 0, this would be 1. So this would be, my x value is 0. And my y value would also be 0 because it's right here on that point. So if I wanted to know the ordered pair of this point right here, according to my definition, I always write it as the x value followed by the y value. So let's look at our number line. If we were to trace this down to our x-axis, it would be found at +2. So my x value is +2. Then I need to look at my y value. So I'm going to put a comma, and I'm going to trace this dot all the way back to the y-axis, which is at +2. So this point is found at 2, 2, and it's also found in the first quadrant. So let's do this one. This point right here. I need to know its coordinates or its ordered pair, okay? So I always look first at the x value. X always comes first. So let's look at the x value. So here's my point, and I look at what it lines up on the x-axis. Well, that lines up to be -3. What is my y value? I look at my point and see where it lines up to the y-axis. In this case, it's 4. So my ordered pair for this point is -3 and 4. So why don't you try this point right here on your own, okay? I've given it to you. I want to see if you can figure out what this number is, all right? What you should have gotten was 3, -2, because its x value is 3 and its y value is -2. Now, try this on your own. Try to find -2, -4. I want you to find this point on this graph, and I want you to tell me what quadrant it is. See if you can figure that out. What you should have had is if you went to your x value, you saw that this coordinate was -2, so we go down to -2. And then the y coordinate is -4, so we go here. And if we bring those down until they touch, here is our point. So this point is our -2, -4. And it's in our third quadrant. All right? So let's go ahead and do some other practice. So here is this, where basically it's telling me to plot the ordered pairs in the coordinate plane and describe the location of the point. What I'm asking you to do is literally take these points, put them on this graph, and then tell me whether it's in what quadrant it's in. So pause the video, try these on your own, and then we'll go from there. Your graph should look something very similar to this. All right, And A happens to be in the first quadrant, B is in the second quadrant, 3 is in the third, 4 is in the fourth, 5 is in the third quadrant, and 6, which was point F, is in this. So you should have yours to look like this. Point A is in the first quadrant, point B is in the second quadrant, point C is in the third quadrant, point D is in the fourth quadrant, point E is in the third quadrant, and point F is in the second quadrant. All right. Now, number 7 goes a little bit more difficult here because it wants us to do something. It says the coordinates of 3 vertices of a rectangle are shown in the figure. So I have some points here. And what's the coordinate of the first vortex? So let's do a little bit of review. We know that the shape we are building is supposed to look like a rectangle. All right, something like this. What we know right now is we know this point right here. We know this vertex. We know this vertex and this vertex. That's what you see, okay? Our job is to figure out what this one is, all right? So we're going to darken this up just a little bit so you can see on the screen, and hopefully you can see that a little better, and we're going to kind of sketch this out. So our rectangle should look like this. Should look like that. And we are trying to find, as I said, this last vertex. So there it is. What is it? Well, my x value happens to be -1, because there it goes. It lines up with -1 on the x-axis, and it lines up with a +3 on the y-axis. So the coordinates for that missing point are -1, 3. So this last question I'm going to leave to you as your challenge question, all right? So you may have to get graph paper for this. Matter of fact, I'm pretty sure you will when I'm looking at the question. But I want you to try this one on your own. And as always, you know how to find me. You know where I'm at. You know where I work. Come ask me questions and go ask others if you need to. And I'll see you in the next video. Bye-bye.